lot of concern about the state of freshwater mussels in Ohio, and they're declining in even some of our highest quality stream systems, in some of our scenic rivers, where everything else is fish and macroinvertebrates and other um, biological groups are going gangbusters. So we're concerned about that, and looking to Dr. Hoggarth to help us out in the future as well, and some other studies, since maybe the Olentangy next summer. So, Dr. Hoggarth, welcome, and thanks for participating in today's symposium.
Okay, so then I'm going to talk a little bit about the Little Miami River data that I just finished this year, 30 years of data, and then a little bit on the status of the mussels of Ohio. And so these are the mollusks that we might find in freshwater in Ohio. And so we have both the bivalves, that's this group right here, and the gastropods, and those are these right here, just the aquatic gastropods. I put some pictures of some mussels along the edge, and there's a number of here that I would like to talk about, but let me just talk about this one right here. Okay, just a little bit of a snippet. In the late 90s at Otterbein University, where I teach, I took a group of students on a canoe float from Alum Creek Dam, just below Alum Creek Dam, to the Westerville Reservoir. And I found just hundreds of these little mussels right here. And this species of mussels was just recently listed for review for federal status as a threatened species. It's called the round hickory nut. And so Megan, Michael, and I from ODOT went over to this area where I found all of these. And this is a juvenile mussel of that round hickory nut that's found in Alum Creek. Still a pretty good population of those mussels in Alum Creek. Anyway, so I'm going to talk a little bit about the snails first, and then the bivalves next. We have two groups of snails that occur in our streams in Ohio, and I put this up here primarily because of this family of snails right here, the Pleurocerids. And here we have a Pleurocerid snail. It's a river snail, and this Pleurocerids snail is found wherever water quality is really good. And so I usually look for this first before I start looking for freshwater mussels, because if I can find this, or in fact, this one right here, which is a larger river snail, then water quality is probably pretty good, and particularly the amount of oxygen in the water. On the other hand, if I'm going out and I find this snail, this is a lung-breathing, a pulmonate snail. If I find this snail, then chances are water quality is not good, or there's a problem with the amount of oxygen in the water. This is a phyceid. The rest of these are pond species, except for these guys down here, the limpets, which are found in streams. So we'll go on. Oops. So these are the other clams that we have in Ohio. We have two introduced species, and I'll talk about these a little bit as we get into the Little Miami River data. So this right here is the Asiatic clam, and then these are the zebra mussel and the quagga mussel, the Dracenids. And so these come into play, and my interpretation of what's been happening in the Little Miami River system. I'm not going to talk about these, but for completion's sake, these are the pea clam, the small native clam, and then the fingernail clams, the thicker one and the thinner one. So let's go here. So let's talk about the freshwater mussels of Ohio. Well, we have 80 species of mussels that have been recorded for the state. 11 of those species are extirpated, and 6 are extinct. The rest are remaining. And of the 80 species, 15 of those species are listed as endangered or threatened by the U.S. Fish and Wildlife Service. 2 others, as I just mentioned, 2 others are currently in review for listing as threatened. And according to DNR, there are 24 Ohio endangered species, 4 Ohio threatened, and 8 species of concern. Freshwater mussels are among the most threatened of all of our species in the state of Ohio. And so why are they vulnerable? Well, many live their life completely buried in the substrate. And so whatever is delivered in the substrate to the bottom is delivered to them. The wartyback that I have here, you can see this shell was not cleaned when I brought it up out of the bottom. That's because it was living its entire life buried in the substrate, and the sand was cleaning that animal off. While feeding, they separate food from fine particles. And so excessive sedimentation can bury them, or it can interfere with feeding and reproduction and respiration. All of those things happen with the gills of freshwater mussels. And so we see, for example, wrapped around this mussel is that fine sediment that it's deposited along the outside of its shell. And they depend on a host to complete their life cycle. So whatever affects their host also impacts them. But they're quite useful. Their nacre, the inside of their shell, is a mother of pearl, and they're used both for natural and cultured pearls, but not in Ohio. It's illegal to collect mussels for pearls, and it's illegal to collect mussels in Ohio to sell to the cultured pearl industry. They are food for other wildlife. You can go to any dam site and go downstream where it has free flowing area. The mussels accumulate in those areas, and so then too will the predators of the mussels accumulate in those areas. Their habitat for other forms of wildlife. We often find pupa of caddisflies on the shells of freshwater mussels. And quite often leeches are found on the dead shells, on the inner surface of the dead shells of freshwater mussels. As I showed earlier, they can filter water and help clean that water. They stabilize stream beds. They anchor themselves with their foot and can keep the stream bed from moving downstream and stabilize those environments. They are good water quality indicators. And by that, I mean they indicate both good water quality or exceptional high quality water, but there are some species that can live in more silt tolerant kinds of places. And so we can look at those to see if they're increasing in number and say something about the sedimentation that's happening in that environment. They have aesthetic, research, and I would say inspirational values that all help with this idea of biodiversity. And there are threats to mussels. This was a scene that I saw on the Little Miami River when I was there, and this last year, and it was they were cleaning out a log jam in front of that pier, and any structure or construction that gets into the stream bed and disturbs the stream bed, of course, would disturb mussels. Anything that covers that stream bed would cover mussels. And so in-stream construction can be a real challenge for freshwater mussels. Dams can be a challenge because they restrict the movement of fish upstream and downstream. The last few years, we've been taking dams out, and before we take a dam out, we've been relocating mussels in the impoundments, and we've been finding that impoundments may not be as destructive as the dam itself. Introduced and invasive species, I'll have a little bit more to say about this later, but these introduced species can outcompete. They can, if it's a zebra mussel, they can attach to the outside shell of a freshwater mussel and then essentially cause that mussel to starve. Water pollution is a problem. The loss of a host species can be an issue for freshwater mussels. It doesn't necessarily have to affect the mussel itself. It can affect those things that fish that are hosts for that. Climate change causing these increasing flooding events followed by drought can be difficult for mussels, and then fragmentation, sedimentation, viruses, other reasons for mussels to die in situ. Okay, so let's talk a little bit about 30 years of change in the mussel fauna of the Little Miami River. Now, just let me say that we don't necessarily have 30 years of data on any other river system in Ohio. This is it. And so starting in 1990 and 91, I went to the Little Miami River and sampled at 105 sites throughout the entire watershed. I had my son with me helping. I had my wife with me helping. I had anyone who would go out with me helping on that survey. And we spent a lot of hours looking at the mussels of the system. Prior to that, Clark in 1948 had self-published a report on the mussels of the main stem, but that was it. This was the first systematic study of the mussels of that system. In 2006 and 2007, Natural Areas in Little Miami Incorporated financed the second study of this watershed. And then this last year and the year before, um, Scenic Rivers funded this last study, 15 years apart in each case. So let's look at some big picture comparisons first. And let me just tell you up front that it's not going to be real good news. So some of it is better than others, but it's not all really good news. And so for the Little Miami main stem, we had a total of 36 species in the system in 1990. 30 of those species came from the Little Miami River main stem. At that time, we collected over 1,200 living and dead mussels. Now, I'm going to explain that one of the great things about looking at mussels as far as environments are concerned and streams are concerned is that we can find them alive. We can find them as freshly dead shells, and that's what that D refers to right there, is a freshly dead shell. We can find them as weathered shells, maybe dead for somewhere between 5 and 20 years, and we can find them as subfossil shells. And so I'm going to refer to the living and dead mussels that we found as the extant individuals rather than just extant species. And so that's, I wanted to make that clear. We didn't find any corbicula. This was an introduced species that would outcompete some of the juvenile mussels. Yeah, 15 years later, we found fewer species. In 2019-20, we found fewer yet, and almost all those losses were in the headwaters. We found fewer number of individuals, but we sampled about half the sites. We sampled 41 rather than 105 sites. We only sampled the best 41 sites, but we sampled those 41 sites. And we used a different method. We used some time sampling for 3 hours and then some quadrat sampling for 10 square meters. We repeated those same methods in 2019-20, essentially the same number of living mussels, but quite a few fewer corbicula, which suggests to us a couple things. One is that whatever was affecting the mussels in the system in the headwaters was also affecting all the mollusks in the system, including the introduced ones. We find that data is even worse in Todd's Fork, Little Miami River. We went from 15 species to 1, and now we have 4 species, but only 5 living and dead mussels were found in that system as we sampled that. We see that in Caesar Creek, we went from 14 to 5 and now 7 species of mussels, but we had a dramatic decrease in the number of individuals that were collected as live and dead animals. From 409, certainly using different methods, but from 409 to 18 and now 14, the decrease is phenomenal. And not only that, but we went from essentially a few corbicula to a huge number of corbicula during 2006, 2007, and the addition of the zebra mussel to almost no corbicula, and all the zebra mussels were gone. And so whatever is affecting the mussels in these 2 streams, particularly Todd's Fork and Caesar Creek, are also affecting the non-native species. And then a little bit of hope at the end. In the East Fork of Little Miami River, we saw the least amount of change. These same data are shown here. The blue line is 1990, 2000, or 1990, 91. Orange is 6 and 7. And then the gray is 19 and 20. Over on the y-axis, we have a number of extant individuals, and so that's the living and dead individuals. And we can see that in the headwaters, that's the far right side of this graph, large number of individuals going down to essentially Beaver Creek, just below Beaver Creek and Xenia. There's some water quality issues right there, then shooting back up again before we go to the mouth. We notice that in between 1991 and 2006, 2007, the number of headwaters individuals declined. and then shot up again. We had some introduction of some species from the south on freshwater drum, and so those species increased their number toward the mouth. And then we have another decrease in the number of individuals in the headwaters, coming up to a point those point at about 22 mile 22 or so was the introduction of those species that had been on the freshwater drum moving upriver. And we noticed that for a number of species, which is on the right, that the same trend is being demonstrated. We have some loss of species in the headwaters, but a dramatic loss of species in the headwaters this last 15 years. East Fork is the same thing, but if we look at the East Fork and just get rid of the blue line, and we look at the orange and the gray lines, we see there's very little change in the East Fork, Little Miami Rivers mussels. So here's some of the highlights. So the washboard, Megalonias nervosa, we found that both in 2006, 2019. So that species seems to be stable in the Little Miami River. That's a state endangered species. The warty back we found in 1991 and 2006, 2007. That one we only ever find when we're doing quadrat sampling, because you can see it's completely buried in the substrate. And I believe that that's probably still in the system. However, I believe that the last three, little spectacled case, bean shell, and snuff box, have probably been extirpated from this system. We haven't found them since 1991. And some of the lowlights are that whenever I go to the stream bed, the first thing I look at are the rocks, and I look for the river snails on top of those rocks, and I didn't find any in the lower portion of the Great Miami River. What I found instead was sediment. I would lift some of these rocks over, and there would be river snails in the bottom of them, but what I found mostly was that the river snails were replaced by the second photograph, which are the pouch snails. And then in other places, I noticed that where we found living mussels like we have down here, and freshly dead shells of these living mussels, we found so many more weathered and subfossil shells than we found fresh. And here's another example of that. And then one last thing was that following rain events, we had streams that look like this up in the right-hand corner. There were some other highlights, though, that I think I should probably mention. It's not all bad news here. We did have large numbers of spikes and kidney shell in the East Fork. We had juvenile mussels that we found both in the main stem and the East Fork, so there is reproduction of mussels going on here. We found a large population of three ridge, which is on the decline in Ohio, in the main stem, and then we had all of these mussels that get attached to the freshwater drum as host in the system. And so the status of mussels in Ohio, 57% of them are listed as rare. Large rivers, the Scioto, the Great Miami, the Muskingum, the Maumee, they're doing pretty well. There are millions of state-listed mussels in these systems. But we don't really know so much about our medium-sized streams, like the Olentangy, the Little Miami, Walhonding, Tuscarawas. They're a mixed bag. Some of them we can demonstrate some decline because we've been out there to look, but mostly we just don't have the information we need. Bob had talked about perhaps doing the Olentangy this next year. It would be 30 years since we got into the Olentangy last to do a survey. Oops. And then the small and headwater streams are suffering. And so we get mussel die-offs like in Darby Creek, and we get the loss of headwater species. There's some real problems here that we just haven't identified, but I believe they're out there. With that, I will thank you for your attention and answer any questions you might have.
Okay, thank you, Dr. Hoggarth.
Yep.
We have some questions here, so let me get those pulled up. Heather asks, do corbicula directly impact native mussels?
Yes, there are data out there that show that corbicula can interfere with habitat for mussels. They live, at least the juvenile ones, they can live in the same environment as those freshwater mussels, and they also compete with them for food. They're eating the same materials as a freshwater mussel juvenile, and uh, and so even in Little Miami, the second set of data, there was a switch point when you had a concentration of corbicula at such a level, I think it was 20 per square meter, that freshwater mussel diversity decreased significantly. Yep.
Okay, and James Spetz asks, what is the net impact of dam removals on the Ohio mussel populations?
Well, I have to believe. I think it's pretty early to tell the what that might be right now, but I have to believe that it's going to be good for freshwater mussels of Ohio, because what it's going to do is going to allow the connectivity of these mussels from downstream to upstream, and we're going to be able to have fish moving in, and then those fish delivering those juvenile mussels to these different habitats. On the Sandusky River, the Ballville Dam, downstream of the Ballville Dam, there was essentially, it was a sediment poor environment. There was no sediment for mussels to actually move into. There was so much sediment behind that dam that that sediment now is being redeposited over the lower Sandusky River. And that's going to be good for mussels because they're finally going to have a habitat where they can live. So I have to believe that the overall impact of dam removal on mussels will be positive.
Okay, great. Mike Eckberg asks, any idea as to what is causing the decline in mussels and headwater streams?
Yeah, I think it's not a single problem. I think it's a multitude of problems in headwater streams. And so I think that, part of it is the excessive siltation that we're seeing in all of our streams. I think part of it is that we have single pollution events that might uh, mussels can they can clam up, and so they're not as susceptible necessarily to acute pollution events as they would otherwise be. But if that pollution event removes a fish host, even for a short period of time during the reproductive season, then that group of mussels no longer has that reproductive ability for that year, or maybe 2 years, or whatever that happens to be. And so there's just so many small things that add up to cause the problems we have in our headwater streams. And I think part of it too is that there's less water, and there's less of a dilution factor in some of these headwater streams, and so all of these things become even more problematic.
Okay, and kind of a follow-up question, similar along those lines, from the Hamilton County Soil and Water Conservation District. Aside
Mhm.
from sediment, what are some of the most important water quality stressors to mussel populations?
Probably the one that I would put, hand in hand with sedimentation would be hypoxia or oxygen reduction. Freshwater mussels are the largest of our benthic organisms. They require quite a bit of oxygen to maintain their mass. And wherever we have an event that causes a decrease in oxygenation, it might be an algal bloom that the algae then die, and we get a hypoxic situation downstream. It could be a number of different things, but that's probably the hand in hand with sedimentation is reduction in oxygen that can occur. And then probably there's uh, construction that in-stream construction that causes problems for mussels. Right now, all mussels in Ohio are protected, and so we relocate mussels prior to known construction activities, but I'm sure that we don't get all of them, and I'm sure that the ones we relocate aren't necessarily doing as well as one would hope.
And one last question, can you comment on mussel bola?
Mussel bola?
Yes, I guess that's a reference to a mussel virus.
Yeah, I would think so, but no, I can't.
That's from Bill Sheeman.
Okay. Yeah, I know that I know that there are viruses out there that people have been examining as causes for muscle die-offs and things like that. It makes sense. I mean, we're in the middle of a pandemic right now. Mussels could be the could be the same.
Thank you very much again, Dr.
Yep.
Hogarth. We
Uh-huh.
appreciate you taking the time. And, from the Scenic Rivers Program perspective, freshwater mussels and what's going on with their populations, particularly in some of our highest quality streams like the Big and Little Darby Creeks and Little Miami River, where we have outstanding fish populations and fish populations are expanding, doing very well, yet we're seeing declines in freshwater mussels. So it's something that we're very concerned about and something we'll continue to look at and try to investigate. And like we've mentioned here a couple of times, already have spoken with Dr. Hoggarth about doing a survey of the Olentangy next year. So everybody out there, if you're interested in the Olentangy, stay tuned for that. And we may see that happening next year. So thank you again,
Bob.
Dr. Hoggarth.